So in solving this equation, one thing we can recognize is that 2 goes into 18, 2 goes into 2 once, 2 goes into 18 9 times. And so we can actually rewrite this equation, 4 over y minus 5 is equal to 9 over y. And the reason why we would do that is to make it just a little bit easier. We can multiply both sides by y, and in an effort to first of all remove all fractions. So if we multiply both sides by y, let me see here, we're going to be distributing, don't forget, you're going to distribute this y to both of the terms on the left hand side. So y times 4 over y, the y's cancel and we just get 4, and then we get y times negative 5, and that's negative 5y, and then the y's on the right side cancel and we just get 9. So just by that one step of multiplying both sides by y, we get a much simpler equation. Then we can just go ahead and subtract 4 from both sides. Doing that, we get negative 5y is equal to 5, and then we would divide both sides by negative 5, and we would get y is equal to negative 1. So let's see if we can do that on the calculator. First thing we want to do, anytime we're solving an equation, we're going to go ahead and let the left side be equal to y1. So y1 is the left side. And a little trick here to make a fraction, if we hit the alpha key and the y equals, notice a little window pops up n over d. That's numerator over denominator. So just to make it look exactly like the problem, we can create 4 over y. Now, for the sake of needing a variable, the only independent variable that we've got here in our calculator is x. So on our calculator, we're going to solve it we're going to call y equal to x. And so instead of placing a y there, we're going to put an x. So 4 over x minus 5, that's our y1. And then our y2, we could do 18 over 2y. Might as well do that for the sake of just rewriting the exact problem the way it's written. So y1 is on the left, y2 is on the right, and let me actually label that. y1 is that whole side, and then we have our y2 is this 18 over 2y, and so that's exactly what we've defined. And we're going to go ahead and just hit zoom 6, and zoom 6 is zoom standard. Okay, so zoom 6, that's the standard viewing window from negative 10 to 10 in both directions. And this gives us kind of an okay picture of what's going on. And we already found out that the solution is actually just negative 1. So when x in this case is negative 1, that solves the equation. So here y is negative 1, that solves that equation. But we're setting y1 equal to y2. Remember, y1 equal to y2. And so what we want to do is get a better look at this. Second, quit that. So we're going to look at the graph, get the graph already. To zoom in, we're going to go ahead and zoom in a little bit lower. We're going to change the viewing window, because we notice that right down here is where the red graph hits the blue graph, but we want to lower the viewing window a little bit. We want to lower the y min maybe down to negative 15, and the y max, we can let the y max be 0. And then the x min, we can see that somewhere between negative 3 and 0, the two graphs cross. So we're really just looking for the graphs to cross. And we see right there is where they cross. And we just want to calculate the intersection point. So second, calculate, intersect. And the first curve is the blue one, the second curve is the red one. And as soon as we mark the blue one, we do that with hitting enter. And then we have the cursor now on the red graph, and we hit enter to mark that. Then we just move the cursor over to the point of intersection near it, and we hit enter, and we see that when x is equal to negative 1, the two graphs cross. So therefore, the solution is negative 1. x equals -1. That's it.